All right, so we are solving absolute value equations today. Tomorrow we'll do the inequalities. And when you're solving absolute value equations with algebra, it's important to understand that the absolute value of a number is the distance from zero. That is why when you take the absolute value of something, it is positive. Okay, and then we can use that definition to solve equations by constructing two different cases. Okay, so the two different cases come from the absolute value Okay, so because you have the absolute value equal to some, we call it B, okay, equal to B, that's going to be one of your cases. Okay, so case one, whatever is inside the absolute value is going to be equal to the value, in this case we call it B. B can be a number, sometimes B is going to be an expression. Okay, and then case two is whatever is inside the absolute value is equal to the opposite of B. Okay, so case two is that whatever's inside the absolute value is equal to the opposite of B. All right, so your steps for solving are on the side here. You are going to start by isolating the absolute value. So you have to get the absolute value by itself. Nothing can be added to it or multiplied to it. Then you are going to write the two cases. You're going to use the properties of equality to solve each case. So the properties of equality, you probably remember from geometry when you had to do proofs. And if you added something to both sides, you'd say the addition property of equality, subtraction property of equality. So the properties of equality are just algebra, using algebra to solve your equation. And then we are going to be checking our solutions. So when you're checking, you have to show the proper steps. And we're going to do examples of those so you'll know exactly what that means. Okay, now absolute value equations, they can have one, two, or no solutions. Okay, so absolute value equations can have one, two, or no solutions. Okay, so because you have two cases, each case is going to give you a solution. But it's going to have a one solution if one of the answers does not meet, they say, the constraints of the problem. Okay, that is called an extraneous solution. Okay, extraneous. And in that case, it looks like a solution, but when you check it, it does not check. Okay, so it looks like a solution. But it does not check, which is why we absolutely have to do step 4, because sometimes it will look like a solution. When you plug it back in, it's not true. Okay, and then there could also be no solution if both cases are extraneous solutions, and this is called the empty set. Okay, and we're going to use this symbol here. It's just a 0 with a line through it. It's called the empty set or the null set. Okay, so we're going to solve each equation and then we're going to check the solution. And again, I'm going to go through with you to make sure that you have the proper steps. Okay, and checking is also something that will be required on your quiz, so we want to make sure we do it right. Okay, so the first thing we're going to do is isolate the absolute value. It is already isolated here. There's nothing added to it or multiplied to it. So we're going to set up the two cases. So you always take what's inside the absolute value, that t minus 4. And in the first case, it's going to be equal to 7t plus 12. In the second case, you still take the t minus 4, but if you're doing the opposite, make sure that you put the binomial in parentheses, because you have to make both of these the opposite. You're going to distribute the negative. Okay, so we're going to solve each one of these for t. I'm going to give you a moment now to do that. All right, let's see how we did. Okay, so you're getting all the t's on one side, and there's obviously multiple ways to do this. So I like to keep the value in front of t positive. We're still working today without our calculator. So when we're reducing the fraction, find a number that goes into both. 2 goes into both, and then you're just going to leave it as an improper fraction. Okay, now with this one, because you had a binomial, you have to distribute the negative. That's why I recommend you put it in parentheses, because sometimes people just put the negative in front of the 7t, and you do have to distribute it to both. Okay, and then again, you're getting all t's on one side. So I'm going to add mine over to keep this positive. And it's perfectly fine if you do this in the same step. Okay, and then you're going to divide to get t equals -1. Okay, so now we're going to do our check. Okay, so with your checks, you are going to do 2 separate checks. The first one is -8/3. The second one will be -1. When you are checking, your first step is to substitute the value into the original equation. So our first steps are all going to look the same. Okay, substitute the value into the original equation. Okay, so when I'm checking your homework, everybody's first step should be the same. So this is your original equation, the absolute value of t minus 4. So it's the absolute value of -8/3 minus 4 equals 7 times -8/3 plus 12. Okay, and then we just put like a little question mark here. So we don't know if they are equal. Because we don't know if they are equal, we can only work with one side of the equation at a time. So the second step is to simplify each side separately. Okay, you cannot use any properties of equality. I cannot subtract the 12 to this side, because if you did that, you would be assuming that it's equal. Okay, so sometimes I even just cover up this side. Now, again, we're doing this without a calculator. Okay, so we need to start thinking about, all right, if I have a fraction and a whole number and I want to subtract, what do I have to have? Yep, so you're going to get a common denominator. So if you put that over 1, what would our common denominator be? Okay, so to get from 1 to 3, you multiply by 3. So if you multiply 4 by 3, you get 12. Okay, and then from there, you can just subtract the numerators. So you have negative 20 over 3. And then you need to make sure that you're doing this step by step. So then you take the absolute value and you get 20 over 3. Okay, so make sure you don't skip any steps here, and then you're writing this out in a very organized and readable fashion. All right, now on this side, when you are multiplying a whole number by a fraction, you can also think of this over 1. So what's 7 times 8? 56. So this will be negative 56 over 3. Do you guys know how to tell if 3 goes into something right away? You can add the digits, and if it goes into that number, then it'll also go into 56. So what's 5 plus 6? 11. And does 3 go into 11 evenly? Nope, so then it won't go into that. So again, let's just get a common denominator. If this is 12, how can I make the top number? 12 times 3, which is here. Okay, so we know it will take a little bit to get some of those skills to come back, and then it'll get easier the more you practice. Okay, so 56 and 36, because this is negative, just find the difference. The negative is going to stay because the bigger number is negative. And are these equal or not equal? Not equal. So if they are not equal, you put a slash through it. Okay, so that's how you show that they are not equal, and that means we have an extraneous solution. Okay. Okay, so when you have an extraneous solution, you do not include this in your final solution. Okay, your work is showing it's extraneous, so when we write out our final answer, that will not be part of it. Okay, and then we're going to check -1. So again, your very first step is to plug it into your original equation. So you have the absolute value of -1 minus 4, and the absolute value equals 7 times -1 plus 12. Okay, and one of my first steps is always to write this here, okay, because I can't do things back and forth over the line. That would assume it's equal. We cannot assume that. Okay, so if I subtract, I have the absolute value of -5. And what's the absolute value of -5? 5. Okay, and then on this side, I would have -7 plus 12, which is 5. Okay, so see, they're not always this intense. Okay, so if they do work out, then that is a solution. So when you're writing your final answer, your solution would be t equals -1. Okay, make sure you don't write 5, right? This is your solution. Because it checked, this is going to be your solution here. Okay? Oh, sorry, I wrote it up here. And you guys are welcome to write it down here. I just made my line too big. Okay, now for part B, we're doing the same thing. So we're solving and we're checking. And we're making sure that we're showing those proper steps. Okay, for full credit on your homework, you have to make sure you are showing those steps. Okay, and then with this one, you do have to make sure that you isolate the absolute value first. Okay, so when you're isolating the absolute value, you can't have anything added or subtracted to the outside. Okay, so the first thing we're going to move over is this -3, or this 3 by subtracting it. Don't forget you have that negative still in front. Okay, and then to undo that negative in front, you will divide by -1. Okay, now once you get there, once the isolated absolute value is there, now you can do your two cases. So when you do your two cases, you can really just write it out like this. Here will be case 1, here will be case 2. You may have done something similar in Algebra 1 when you first learned how to solve absolute value. Now, case 1 is always just what's inside the absolute value equal to whatever you have on this side. So it is -12, so we have it there. Case 2 is the opposite of what you're given. So again, it's whatever's inside, and then the opposite of -12 is 12. Okay, so I want you to solve both of those for R. And then we will do our checks. Okay, make sure that you leave your answers as an improper fraction if it's not a whole number. And don't be scared to do this without me. You guys know how to solve. All right, looks like you guys are doing a great job with that. All right, so double check that you also got -18/5 and 6/5, and then we are ready to check. Okay, so each one gets their own check. I'm also fine if you just write the CK there. Okay, so the first step is always plugging it back into the original. So whatever the original problem is, that is where we're going to substitute. Okay, so we have 3 minus 6 plus 5R. And that is equal to 15. All right, so then when you are solving, okay, think of your order of operations. You got to start inside your grouping symbols, and then you can multiply before you add or subtract. Now, when you're doing this, don't multiply by 5 and then divide by 5. What happens if you multiply something by 5 and then divide it by 5? which is what number? Oh, yeah, because 5, what's 5 divided by 5? 1, right? So 1 times negative 18 is negative 18. So, yep, that is what you're left with. And again, I'm going to put my line down here. So this is going to be 6 minus 18 inside the absolute value. And then you still have the 3 minus out in front. Okay, and then you do need to just do this step by step. So you're doing the absolute value of negative 12. So that might be tough for some of you to just slow down a minute. But you need to show what you have inside the absolute value. And I'm fine if you make these like a little more pronounced if that helps. Okay, and then the absolute value of negative 12 is 12. But this minus is going to stay there. So 3 minus 12 is negative 9. Okay, well this side is just 15, right? So we don't even have to do anything there. Are those equal? No. Okay, so if it's not true, I want you to cross that out. Okay, so put the not equal. Okay, don't leave them equal to each other if they're not. Okay, and then this is an extraneous solution. Again, you don't have to write that on your solution line, and your work is going to verify that it is extraneous. Okay, and then we're going to check for 6/5. So 3 minus 6 plus 5 times r, and then equal to 15. So again, I put this line down here to show I can only work with one side at a time. And this is nice because again, this cancels out, right? So inside you get 3 minus, and then you have 6 plus 6, which is 12. 3 minus 12 is negative 9. This should feel very familiar. And then again, it's not true. Okay, so it's another extraneous solution. So do you guys remember what we talked about? If they are both extraneous, yep, it's going to be the empty set. So you can write your solution a couple different ways. Okay, you can just use the empty set symbol, which is this. Or if you want to write no solution, you can write no solution. You can abbreviate. Okay, and that is your final answer. Okay, just remember that means the empty set. You're welcome to use that symbol, or you can just write no solution. Okay, so for part C, we want to isolate this absolute value. Okay, John, can you help me with that? What would I do first to get the absolute value by itself? What do I have to move over? Yep, we're going to divide both sides by 3. So that will cancel. And now you will have the absolute value isolated. Now remember, you can divide this. It's just negative 2w. And we're going to set up our 2 cases here. Okay, so we take a moment and write out those 2 cases, and I'll ask you to help me in a minute. And then if you want to start solving them, you can do that as well. Okay, and then Caleb, can you tell me what you put for your first case? Yep, 7. Say it again. Yep, so then whatever you have in the absolute value, okay, you can just use the -2 because that's what it gave you. And then for the second one, yep, you'll just do the opposite. Yep, great. Okay, so then we want to get all the W's to one side. So the quickest way to do that is to subtract 7W from both sides. And then we're going to divide. Okay, and then Lucas, can you tell me what number goes into both 15 and 9? 3, good. So I'm going to divide them both by 3. That's going to give me my final answer. Okay, now notice here the steps are the same. You're subtracting 7W from both sides, but now you have -5W. And we know that -5 goes into 15 evenly. Okay, so now we're ready to do our 2 checks. Okay, and I know sometimes the checks feel like a lot of work. This is part of your process to make sure you don't have an extraneous solution. Okay, the check is very similar to a proof. It's just I don't make you write out any reasons for it. You just need to show your mathematical steps. Okay, and again, you are using the original equation. All right, and we'll do the fraction one together, okay? Do we need some practice with the fractions? Been a while. Okay, so again, think of this over 1. When you're multiplying fractions, you're just multiplying straight across. So 7 times 5 is 35, so I have -35 over 3. And then once you have that fraction, and you see the next one's a whole number, go ahead and make the denominator the same. Okay, and then what you're going to do is you're just going to multiply the denominator by that whole number. So if you don't know 3 times 15 right away, just add 15 plus 15 is 30, 30 plus 15 is 45. And if you have a negative, it's subtraction. So you're just doing 45 minus 35, which is 10. So this is 3 times the absolute value of 10/3. Okay, the absolute value of 10/3 is just 10/3. So you can replace it with parentheses or you can replace it with a times. And then what happens to your 3's? They cancel out. If you wanted to multiply, 3 times 10 is 30. 30 divided by 3 is 10. You could absolutely do that. And then here, a negative times a negative is a positive. 30 divided by 3 is 10. And then if it's true, I usually put like a check just to show, yep, I checked that. It's true on both sides. Okay, do you guys want a chance to write out your steps for this check? See if we can do it. So first step is substitution. All right, and then if you want to do the simpler side first, because you know if it's just going to be 18, please feel free to do that. Okay, and then you get negative 21 plus 15, which is negative 6. The absolute value would be 6. So you would end up with 18 is equal to 18. Okay, so if they're both equal, when you're writing your solution, you're going to connect them with an OR. So your solution would be that W equals negative 5/3 or W equals negative 3. The reason why it's an OR is those can't happen at the same time. It can't be negative 5/3 and negative 3. Okay, they both satisfy that equation. So they are both possibilities there. Okay, so I'm going to give you guys time to work on your homework. Again, with your homework with this, I'm checking to see if you have your checks. So if you don't have your checks written out, then you won't get full credit for that assignment. Like I said, this will be a similar setup on your quiz. Okay, and that is part of your process. And then I decided that the 2-2, because we're splitting it up into 2 days, I'm not going to make your homework due until after we go over tomorrow's lesson. Okay, so I'm going to show you the calendar.